This is not going to take long. Okay. So trig functions of any angle, meaning in the last class we were doing, since it was right triangle trigonometry, it was all in the first quadrant. So the angles were all, we said, acute angles between 0 and 90. This is saying, okay, now our angles can be anywhere around the coordinate plane. They won't just be 0 to 90 anymore. Right, so the terminal side of the angle can be anywhere in the coordinate plane. Right, the initial side is always on the positive x-axis. So if you have a point which is on the terminal side, then for that point, you'd be able to define the x-coordinate and the y-coordinate, and you would define the 6 trig functions like so. Right? The sine now is y divided by r. Well, the r is the radius, right? The y takes you up this way, right? There's y. The r is the direct distance from the origin to that point. And since this is the x, right, how are we going to find the length of that side? Pythagorean theorem. Right? So the radius is the square root of x squared plus y squared. So as a first step, you're probably going to calculate the r first. Right? Well, if you know your point, calculate your r. R has to be positive because you assume the square root is positive. And so the y-coordinate divided by r is the sine. The x-coordinate divided by the radius is the cosine. The tangent is y over x. The cotangent is x over y. The secant is the flip of the cosine, so it's r over x. The cosecant is the flip of the sine, so it's r over y. Right? Notice that when you're dividing by a variable, then you've got to say that that variable does not equal 0. That's here, 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 and here. R is defined as not 0. If the radius was 0, where would you be? What point is it that has the radius of 0? The origin, right? You'd be at the origin. So you wouldn't have a side there to have a terminal side. So the R is defined as not equaling 0. You know, we had definitions at the beginning with the unit circle, which all were sine equals y, cosine equals x. There was no r because what was the value of r? 1. It was a unit circle, right? And then in the last lesson, it was all in terms of opposite over hypotenuse and adjacent over hypotenuse and all that. Okay, all these are consistent with each other. You know, given the size of the circle and where you are in the coordinate plane and all that stuff. We good? Ready? Keep going. If you got to finish it, finish. Thomas? You're good? Okay. I thought I saw you copy. So for example, this is the first example. It says, if the point is -3, 4, find the 6 trig functions. Well, actually it just says find sine, cosine, tangent, but we'll find them all. What do we need first? The radius, right? We need to know the r. So first step, we'll say r equals the square root of -3 squared plus 4 squared, which is the square root of 25, which is 5. Okay, this is the x, and this is the y. So now just fill in on every one of these here. We'll fill in for the x, y, and r. Right. So the sine y over r will be 4 over 5. Right, cosine is -3 over 5. Tangent is y over x. cotangent would be -3 over 4. The secant, which you can do this, r over x will be 5 over -3, or you could just think of it as a flip of the cosine. So that is 5 over -5/3, and the cosecant is 5/4. Right. So first step, you got to find the radius, and then just use that point with these definitions. Good. You good, Taylor? Okay. So given that the tangent equals -5/4 and the cosine is greater than 0, find the sine and the secant. Now, when you do these kinds of problems, you got to understand what are the signs, meaning SI, G, and S, of all the trig functions in the particular quadrants that you're in, because otherwise you don't know where to draw the terminal side, right? So this information here, if you don't know it just by common sense, that you're going to have to figure out a way to understand this. I mean, starting with, in the first quadrant, we know that both x and y are positive, right? That would mean that the sine, which is the x over r, and r is always positive, the sine is positive, the cosine is positive, the tangent is positive. In the second quadrant, because x is negative, that's going to make the cosine negative and the tangent negative. Right? In the third quadrant, they're both negative, so sine and cosine are negative, but now tangent is positive, right? Because since you're dividing the y divided by x, if they're both negative, then the tangent is positive. And the fourth quadrant, the x is positive and the y is negative. Okay, well, the x is cosine, so that's positive. The y is sine, so that's negative. And the tangent y over x has to be negative. We will end up using this stuff over and over and over again. It'll be like the common thing that makes us get things wrong sometimes is we don't understand which quadrant that we're working in. I'd say you have to understand the quadrant that you're in and the signs, SIG and S, of the functions. And also understand that when you're drawing your picture, the terminal side always emanates from the origin, right? If we're drawing an angle like here's the one side, right? You got to have the second side that starts from there, right? It's always starting from there. Unfortunately, a lot of times it's like you end up with triangles like that or something, which is just that's not how the angles are drawn, right? They always start with the vertex at the origin. And when you start drawing things like that, that's like you're not going to get all the credit for that. You're probably going to lose significant credit because you're not even setting up the triangle correctly, right? They always start with the vertex at the origin. So this problem that we were doing, again, let's try and figure out which quadrant are we supposed to be in if the tangent is negative and the cosine is positive. Which quadrant are we in? Right? Tangent is negative, cosine is positive, you're in quadrant 4. So you should be drawing yourself a triangle, and let me do this. Wait. So we've already said we're going to be in this quadrant. And go back to that, and blue. So what I would do, I mean, at this point, it doesn't really matter the exact where this line is. It just draw a line somewhere out into the fourth quadrant and label, well, I'm trying to think here. You know, I want to not confuse this, but the tangent of theta equals -5/4. You know, we look at the theta to be like that. But in the end, the triangle is where the triangle is right there. So if tangent is, if you're drawing your triangle, and this is just getting a little bit ahead, but if this is the angle in the triangle, which is our, I'm going to just call it a reference angle for now. If the tangent equals 5/4, what are the lengths of the sides that we can label, right? This would be the opposite side. This would be the adjacent. So it's going to be a 5/4, and one of those is negative. Which one is negative? The 5 has got to be the negative. Okay. And the radius, now we have to fill in so we can answer the rest of the questions. The radius will be the square root of 4 squared plus negative 5 squared. Okay, square root of 41. Okay, so now we're going to say that the sine of theta equals, like using this triangle, the sine should be opposite over hypotenuse. Okay, negative 5 over root 41. Which is rationalized negative 5 root 41 over 41. Okay, the secant. Okay, the secant is 1 over the cosine. So the cosine would be 4 over the square root of 41. So the secant is root 41 over 4. I just flip it. I guess if we were doing this really by the way of this section, you would say it's r over x, right? This one is y over r. So the main thing is you got to know which quadrant that you're working in. Draw yourself a terminal side which is in that quadrant, and then use that to label 2 of the sides. And everything else will work out from there. Now, I kind of already used this term, but reference angle means that when you're drawing this line out here, the reference angle is always the angle with the horizontal axis, okay? See what they're saying here? Now, what do they mean by the horizontal axis? I mean, they mean with the x-axis, but it's not necessarily with the positive x-axis. So wherever you are, right? If I, let's see, I can do this. If I'm in this quadrant, right? If that's my point, or my point is, the reference angle is here. And by reference angle, when they say reference angle, they're using this notation where they're using theta with a little hash on it. I mean, you call that prime. It's like theta prime. So this is theta prime. This is still theta. Theta is the angle with the positive x-axis. Theta prime is this angle with the x-axis, which is actually the negative x-axis. It's with the closest horizontal axis, right? That's theta, that's theta prime, right? If I was in this quadrant, right, then this would be theta. Come on. That's theta. But the theta prime is just this part right here. And what if I was in the 4th quadrant? Theta is this. This is kind of what we just did in that problem. That was the theta. And this is the theta prime. Now, what do you know about the measure of these theta primes? Could they be more than 90? No, in a way, by defining the reference angle, what you're saying is you're always going to use acute angles. So you're going to do things like we did in the last section. And then just apply the sine, S-I-G-N-S, that you know is appropriate in that quadrant. So just go ahead and find the acute angle, which is with the nearest x-axis, do the problem, and then apply the correct SIGN. Right? So first we find a few reference angles. We said theta equals 300 degrees. What is the reference angle? Okay, let's see. Which quadrant is 300 degrees? Fourth quadrant, right? Because it's 270 around here. So 300 would be about right there. So there's theta equals 300. So what is theta prime? Theta prime is 60, right? It's 60 from here to the positive x-axis. Okay, 2.3. Is that in degrees or radians? That's in radians, right? So let me see. Which quadrant would 2.3 be in? And this is where we make a lot of mistakes here too, or I think we find this to be a challenging part of it. Which quadrant would we be in if our radian measure of the angle was 2.3? Well, just think. Pi is here. What is the value of pi? 3.14. It's less than that. So it has to be somewhere in here, right? And half of pi, if this is 3.14, this is 1.57. So which quadrant is 2.3 in? It's got to be here, right? So this is the theta prime. So how can I find this angle? Right, this is 2.3. Theta equals 2.3 radians. And this is pi. How do I find this? Subtract. Right, that'll be the difference. So theta prime will be 3.14, and I am just rounding off, 3.14 minus 2.3, which is what? 0.14 0.74, 2.74. Say again. 0.84. 0.84. That's right. So it's a subtract. Okay, and then the negative 135. Which quadrant are we in if our theta is negative 135? 3, right? Because negative 180 would take you all the way around to here. So and negative 90 would take you to the negative y-axis. So between negative 90 and negative 180 would be negative 135, right there. So there's negative 135 degrees. Okay, what does that make theta prime? Okay, if you're confused about it, find a coterminal angle for that that's between 0 and 360. How do you do that? Add 360, right? What do you get if you add negative 135 plus 360? 225. Okay, so if I said this angle is 225, now how do I find this? Subtract 180, right? This is 180. So if you want to know this distance right here, just subtract. That'll be 225 minus 180, 45 degrees. Okay, Reva? Okay. Okay, so reference angles. Oh, I already did them all. I forgot I put in a slide for each one of those, so that's okay. Now, using reference angles, the cosine of 4 pi over 3. We'll play along, I guess. The cosine of 4 pi over 3. The thing is that most of these here are unit. These are unit circle angles. that you probably would use reference angles to do it, but this is what they mean by it. Okay, so let's say we're doing the cosine of 4 pi over 3. Which quadrant are we in? Right. Remember, this is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So this is 4 pi over 3. Okay, what does that make the reference angle? Theta prime equals, what is this right here? And if this is 4 pi over 3, and this is 3 pi over 3, then what is this? It's pi over 3, right? I mean, if you just subtract 4 pi over 3 minus pi over 3. So using reference angles, you would say, okay, well, what is the cosine of pi over 3? Right? Go to the unit circle and say the cosine of pi over 3 is 1/2. Right? So you find the cosine of pi over 3 is 1/2, and then you say, yeah, but I'm in the third quadrant. What's the sign of cosine in the third quadrant? It's negative, so this has to be negative 1/2. So first we're just doing it for the acute angle, which is the reference angle, and then we're just using our knowledge of where are these positive and negative. Like tangent of negative 210, right? If we did the reference angle, right, negative 210 would be in which quadrant? It's more than negative 180, but less than negative 270, so it'd be like about right there. There's our negative 210. So what is the reference angle, theta prime? $30, right? It's negative 210 is 30 degrees past negative 180. So the theta prime is equals 30, and it's positive. Okay, so we're going to find the tangent of 30 degrees. Right, well, 30 degrees on the unit circle is right here, right? So the tangent would be the y divided by the x. 1/2 divided root 3 over 2. Right, that would be 1 over the square root of 3, which is root 3 over 3. Okay, now what is the sign of the tangent, the SIGN of the tangent in the second quadrant? It's negative. So this has to be negative root 3 over 3. So when you're using the reference angles, everything's going to be positive, and then you have to apply the correct SIGN. How about 11 pi over 4? Which quadrant are we in? Well, let's see. 11 pi over 4, why don't we find a coterminal angle which is recognizable? Subtract 2 pi, right? So 11 pi over 4 minus 2 pi would be minus 8 pi over 4 is 3 pi over 4. Which quadrant are we in? 3 pi over 4 is, right, pi over 2 is here, pi is here, 3 pi over 4 is here. Right? So you can call that 11 pi over 4, you can call it 3 pi over 4. Theta is there. So the reference angle is this. What is that angle? It's pi over 4, right? I mean, if this is 3 pi over 4, which we just said it is, and this is pi, then what's the difference between those? Pi over 4. So we would say the cosecant of pi over 4. Well, cosecant is 1 over which one? It's 1 over the sine. So go to our unit circle And at pi over 4, the sign is root 2 over 2, right? So we would say the cosecant of pi over 4 is root 2, oh, sorry, there. It's 1 over the square root of 2. It's actually the square root of 2. Right? If you flip that and rationalize, you get your root 2 over 2. Now, what is the sign of that in that quadrant? The SIGN. It's 1 over the sine, and so it's going to be the same as the sine function, SINE. Is sine positive here or negative? Sine is like a y coordinate, so it's positive. So this one is positive. Just remember, you're always making your angle with the x-axis, always. And the terminal side starts at the origin. You keep those things straight, you have a chance. I mean, I tend to use this just kind of like intuitively when we're doing any kind of thing. I immediately am trying to think which quadrant am I in, and I'm drawing a triangle without regard to the sign SIGN of anything. I'm just drawing a right triangle in the right quadrant, labeling the sides, and then knowing where everything is positive and negative. Okay, the last thing, they still have a little bit more of this stuff that they're doing. We might as well do it. I think that this is a change from the book last year. Somebody must have identified an issue with this, because this is the third section in a row that they've had us using the calculator to do some of these things. Now, I would think that in a way, just because of where it falls in the section, we just talked about reference angles, and it could be that they want us to do reference angles here. But I don't know why you do that in the end, because some of these things, in fact, all of these, none of these are unit circle values. In the end, you would have to put it in the calculator anyways. So I don't know why you would find the reference angle and then play the games with what is it, positive or negative. You're just going to put it in the calculator. Like, how are you going to put cotangent of 410 in the calculator? Okay, either you're going to do 1 divided by the tangent of 410 degrees, or you're going to do the tangent of 410 degrees, and then you're going to hit the x to the minus 1. And what do we get? Okay, and you're in radians. Let's see if that would make a difference. Is the question I've got anyways. Tangent of 410 x to the minus 1. That's interesting. Because you use the degree symbol, you didn't have to put it in the mode. I wanted to know that. Glad you did that. So what did you get? 839.839. Okay. What mode did you have the calculator in? Degrees. What Taylor just did, which I found kind of interesting, is she did not put her calculator in degree mode, and she got the right answer. And you know how she did? She used the degree symbol. She was in radian mode, but she did the tangent of 410. She went to the second angle 1 and put the degree symbol, and then there wasn't any confusion about what it was. It did the right thing. And I didn't know I kind of had that question to myself. I wonder if I use the degree symbol, whether I have to be in degree mode. No, you don't. What about the sign of -7? Is that in degrees or radians? Radians, because there's no degree symbol, right? So that you just put in the calculator. The sign of -7, make sure you're in radian mode. Paper's jumping ahead, I know. -0.657. negative 0.657. And let's see, sine of secant of pi over 9. How are you going to put that in the calculator? One over cosine, right? So either do 1 over cosine of pi over 9, or you're going to do cosine of pi over 9, and then you're going to 2 to the negative 1. And what mode are you going to be in? It's got to be in radians, right? The fact that you use pi, it's not like using a degree symbol makes it in degrees. And what do we get for that, Taylor? 1.064. Any questions about using your calculator to find these reciprocal functions? And we understand the mode. I mean, it's always something you just need to be asking yourself. What mode do I need to be in? And that's it. Now, the 75 to 89, that looks like a lot, but they're just put them in your calculator thing. These are all just evaluate with your calculator. So I don't think that's actually going to be that much work. There's one word problem at the end.